All right, so put a problem on the board here. I show a little diagram to give it some context. All right, a beetle runs from point B towards C at 12 feet per minute, starting at B at time equals 0 for context. AB is 7 feet. Find out how fast theta is changing at time equals 2 minutes. So they want, there's theta. Does everybody agree that this problem is asking for d theta dt when time equals 2 minutes? All right, that is the unknown. Now, I can put some of this stuff in context. I would put 7 feet right here, right now. You guys agree? That's fixed. We've got the dung beetle running perpendicular to the 7 feet. But I am not going to call this, and you guys might say right away, it's 24 feet. I agree. But I'm going to call it y. Right? Because I'm going to fix notation, and it is changing on the vertical distance. So I want that. I do agree at t equals 2 minutes that y is 24 feet. Right? And that might help us later. What's the other thing I know based on this? I set the notation I've set. Yeah, I'm asking you, what do you think that means? How do I represent this? dy dt. Yep. dy dt is 12 feet per minute. Positive or negative? Positive, because y is getting bigger. The beetle is running away from us. All right. Maybe there's someone here with their shoe trying to crush said beetle. That's a shoe getting ready to crush a beetle at point B. So the beetle is scurrying away. All right. All right. Half of these problems now is, you probably understood all this. The hardest part now is right now. What equation do we want to use? There are a lot of them to pick from. There is one choice that is clearly better or easier. All of them work. You could pick sine, cosine, tangent. All of them probably would work, okay? I think the easiest one at this point is tangent. All right? And that's because since 7's not changing, all right, and that's the key here, that we want to set up the equation now, and I'll use red, that tangent of theta is equivalent to y over 7. And you're usually pretty good at this. And now, because of the calculus aspect of this problem, I think of it this way. And I think it helps a lot when students can see this. The tangent is 1/7 y. And I say it this way because when we take the derivative now of 1/7 y, which, since we're going to try to figure out how fast, right, we got to get there. But this becomes just 1/7 dy dt. It just, sometimes students see it better. Either way, you should see it. So now we got to take the derivative. I'm going to change the scale on the screen. Work our way down. So derivative of this. Derivative of tangent is secant squared theta, correct? D theta dt. There we go. That's what I got to find. Equals derivative of 1/7 y is 1/7 dy dt. What do I know? Well, I know 1/7. I know dy dt. I wrote it up over here. I'm looking for d's theta dt. That's my unknown. And then the one that usually students just choke on, especially if there's no calculator section. Secant squared theta. All right. Well, at this instant, I'm going to pull this triangle, the red triangle. I'm going to draw it down here. For the secant squared, all I really need to know for secant squared is this. We know those two legs right now. Do you guys agree? And we know that this is here. So a quick Pythagorean theorem of this situation, and then it depends, it depends on what's going on. 24 times 24 plus 49. Oh, this is a triple. So much for not doing a triple. It's 25. Darn it, Batman. All right, so the point is, this gets a little prettier, all right? I should have gone 3 minutes. So everybody, here's where students screw up. Most students take the time right now to find the angle. Do not find the angle. This is a ratio. This is a ratio. It's 1 over cosine squared. And I wouldn't care what decimal that was. I would have put it out there, all right? So this is 7/25 squared, right? d theta dt equals 1/7, and we agreed dy dt was that little beetle scurrying away at 12 feet per minute. What's the unit on secant? Why didn't I put any units here? Better question. Why didn't I put units on there? Triangle. They cancel, right? 7 feet divided by 25 feet is just 7/25, right? There's no units. All right, so I put 6/25 over 49 d theta dt, because 1 over, I squared it and moved it, equals 12/7. All right, feet per minute. And I guess I should make sure we recognize that there was feet on the 7 going all the way back, right? The units up here were feet the whole time on that 7. Because what happens here then is that this is unitless, feet cancel, right? So I have 12/7 per minute, but we don't like saying 12/7 per minute, so we put in the word rads. So I have to multiply both sides by 49 6/25, right? And at least some of the math is easy here. So I think my answer is 84 625 rads per minute. And we have found the answer. Now, to put some context in that, because that doesn't mean much to me, for degrees. That does not mean much to me, all right? So it's 0.1344 rads per minute, all right? So I can multiply that by 180 and divide by 2.145. Guys, it's moving about 7 degrees a minute right now. 2 minutes later, it's moving about 7 degrees per minute. Now what's going to happen as the vehicle gets really far away, eventually, what happens? All of a sudden, it barely moves at all, right? Initially, it moves quite quickly, but eventually it gets in and moves very little. So, run, beetle, run. The AP test is coming.